We are now going to learn more on bipartite graphs in Python. Now, as in always, the first step is importing NetworkX as NX. Right? Now, I'm going to create bipartite graphs. Let me tell you how to do that first. Now, bipartite is not present directly inside NetworkX. Like how we did for Eulerian and all, we cannot do it that way here. So what I'm going to do is from NetworkX dot, do you see all these here? These are sub-libraries, right? NetworkX.algorithms, I'm going to choose this. From NetworkX.algorithms, I'm going to import bipartite. So in the sub-library called algorithms, bipartite is present. Now, so bipartite has got loaded. I'm going to create this graph B, let's say, as nx.graph. Oh, it was caps, so let me do it nx.graph this way. Now, I'm going to add nodes to this graph from add nodes from this list 1, 2, 3, 4 and 5, right? So this is it, and I'm going to tell that bipartite is 0. So this means that this is the first set or the first partition. Clear? You see that in bipartite there are two sets, right? So this is going to be my first set. Now, I'm going to again give b.addNodes. I'm going to change this list now. I'm going to give it something like this. Say A, comma, B, comma, say C. So this is going to be my second set and I'm going to name it as bipartite equals 1. So did you see what I just did? I've added nodes, one set from this list, another set from this list. Clear? Now, the next step is adding edges. B.add edges from, I'm going to specify a list now again. So it's going to be something like this, 1, comma A. And then, okay, there is a small trouble here. Yeah, one more bracket. 1, comma A, and then let's say 1, comma B, let's say 2, comma C, okay, and then let's say 2, comma B, and then 3, comma let's say C itself, and then 4, comma A, and then 5, comma B. So these are the edges in my graph, and now I'm going to draw nx.draw B. Okay, we'll specify the labels with labels as true. So do you see the graph here? So this is a bipartite graph with the two partitions 1, 2, 3, 4, 5 and ABC. Right? If you probably write down properly as two sets like how we have showed in the videos, you can verify this by that method. Now, let us check another graph. Let me say we are going to verify if the given graph is bipartite or not. How are we going to do that? Let's say G is equal to nx dot path graph, and let me say 4 nodes. I've created this. So what am I going to print? Print bipartite dot. You see, we can check various things here. So I'm going to check is bipartite now. So print bipartite.is bipartite. So what are we going to check? If this graph G is bipartite or not. It says that G is bipartite. So a path graph on 4 nodes is bipartite. Now let me say G path graph on, let's say, 5 vertices. Let us check if this is bipartite. Or let me call it as H here. Okay, G itself. Fine. So let it be G now. This is also bipartite on 5 vertices. Now, let me consider another graph. Say H is equal to NX dot star graph on, let's say, 10 nodes, right? Let us check. Print bipartite is bipartite. H it is now. This is again bipartite. So bipartite.is bipartite is the command where we verify if a graph is bipartite or not. Let me take a random graph. Let me say K is equal to NX dot GNM. Random graph on, let me say 15 vertices, 15 nodes and say 16 edges. Right? Now let us check if K is bipartite. So how are we going to do it? Print bipartite.is bipartite of K. It says it is not bipartite. Now let me clear the screen. We will now be seeing if we can check if a particular vertex or if 2 particular vertices are in a set or not. What do I mean by that? If a graph is given and if we see that the graph is bipartite, then we can check if particular nodes are in a partition or not, in one particular partition. You'll be able to understand once I do it. Now, let me say create a graph G is equal to NX dot path graph on, let's say, 4 vertices. So the graph has got created. Now let me draw that. NX dot draw G with labels as true. So this is the graph. Now observe what I'm going to do. Let me take this set X as set 1, 3. If you observe here, 1 and 3, these 2 vertices are not connected. Hence, they will fall into one partite set. Right? So we are going to verify that now. Bipartite dot is bipartite underscore node underscore set, and of which graph? This graph G and this set X. So now this is going to give me the answer if these 2 nodes 1 and 3 are in a bipartite set or not. See, it says true. So 1 and 3 fall into one partite set. Now I'm going to go ahead and create this set. Let me say 1, 2. Okay, and I'm going to check if this set forms a partite set or not. G, Y. See, it says false because 1 and 2 are connected and hence these 2 cannot fall into the same partite set. I hope with this it was clear to you how we create a bipartite graph, how we can verify if a graph is bipartite or not, and how to check if particular vertices fall into one partite set or not.